Hello students, welcome to engineering mechanics course. In this class today we will see equilibrium of concurrent force system, and we will also solve one numerical example based on that. So what is equilibrium condition means? What is equilibrium of concurrent force system? Equilibrium means when the body remains at its original position or steady condition even after application of external forces, it is known as equilibrium condition. It means when you apply the forces on body, the body does not shift from its original position. The body remains at its original position, or which is also called as body remains in steady condition. That condition is called as equilibrium condition. So when the body is in equilibrium condition, resultant of force system is always equal to 0. And if resultant is equal to 0, it means summation of fx equal to 0 and summation of fy equal to 0. So these are called as equilibrium conditions of concurrent force system, that is summation of fx equal to 0 and summation of fy equal to 0. Okay. Now if the body is in equilibrium, in the numerical examples, question is asked to determine some unknown forces. Okay. So we will solve one numerical example to understand how to apply equilibrium conditions to solve the numerical examples. So if you look at this problem, there are two signals attached to two poles with the help of cables. This is left cable number pole number 1 and this is pole number 2, and there are two signals, signal as point B and signal at point C, which is connected to these two poles with the help of three segments of cables. So cable AB, cable BC and cable CD. Okay. Now if you imagine how this body is a condition of equilibrium. If you look at now, when these cables are attached to two poles and these two signals are suspended from point B and C, after suspending the signals, if you look at this setup, now this is in steady condition, right? So this is called as equilibrium condition. Body remains in a steady condition. So this setup is in a equilibrium condition. Question is, two traffic signals are temporarily suspended from a cable as shown. Knowing that the signal at point B weight 300 Newton. So this signal weight is 300 Newton given to you. Determine the weight of signal at point C. Here this weight we have to determine. Let us assume this is weight C, WC. Now the body is in equilibrium, that is steady condition, therefore summation of fx equal to 0 and summation of fy equal to 0. We know these are the equilibrium conditions. Now before starting the solution of problem, we have to work out the angles of cables, cable AB, cable BC and cable CD. So if you look at based on the dimensions which are given, if you consider this triangle to find out the angle of cable AB, this triangle if you consider, this horizontal distance is 3.6 meter, and now vertical we can calculate, total is 4.9 and this is 3.4. So if you deduct 3.4 from 4.9, you will get this distance is 1.5 meter. Then if you apply tan of theta, if you assume this angle is theta, this angle is theta, so tan of theta is equal to front side, that is 1.5 divided by adjacent side, that is 3.6. Okay, this is value of tan of theta, 1.5 upon 3.6. So if you find out theta, that is tan inverse of this ratio, the answer is coming 22.62. Similarly, if you look at the segment BC and if you construct this triangle, so this horizontal is 3.4 which is given to us, and vertical is equal to 3.8 minus 3.4. Vertical is 0.4. So again, if you apply this angle, if you assume theta 1, tan of theta 1, if you apply, tan of theta 1 is equal to front side is 0.4 and adjacent side is 3.4. So if you find out that angle, it is coming 6.71 degree. Similarly, third triangle in third segment, if you look at this triangle, okay, so this vertical side is 4.5 minus 3.8, it is 0.7, and horizontal is given to you, that is 2.4. Tan of theta 2 is equal to, if you take tan of theta 2 is equal to front side is 0.7 divided by adjacent is 2.4. So angle is coming 16.26. Okay. So these are the angle calculations first which are required. Now cable AB, cable BC and cable CD. All of you please note, whenever cables are attached to a body, these cables are subjected to axial tensile force. Tensile force means which is going away from the joint, like this. This is called as axial tensile force. This one, like this, going away from the point B. This is going away from point B again, or at point C away, like this. You can show the tension in. This is called as tension in cable segments. So this is tension in cable AB. This is tension in cable BC, which is same. This tension and this tension is same. Then this is tension in cable CD. So please note, whenever cables are attached to a body, cables are always subjected to axial tensile force. Tensile force means force which is going away from the joint. Okay. Now if you break the cables and consider joint B, if you break the cable here like this, if you break it, all three segments. So this is joint B and joint C you can draw separately. So if you look at this figure, right, this one, this is, we have drawn the joint B separately. Now at joint B, first force is weight of signal B, which is given to us 300 Newton, weight of signal B. Then one cable is this one, that is cable BC. So this is tension BC, tension in cable BC. Its angle with respect to horizontal we have calculated 6.71. Then this cable is called as tension in cable AB, which has the angle with respect to horizontal 22.62. This is in second quadrant, this first cable in first quadrant, and weight of signal is vertically downward. Now question is to find out tension in segment AB and tension in segment BC if the system is in equilibrium. So equilibrium means summation of Fx0 and Fy0. So to apply these equilibrium conditions, first we have to resolve the unknown forces into x and y components. So since tension BC is in first quadrant, x component is plus, y component is also plus. The value of x component is tension BC cos of 6.71. Since angle is 6.71 with respect to horizontal, this one. So this is cos and this one is tension BC sine of 6.71. Sine of 6.71. So both are plus because it is in first quadrant. Now tension AB is in second quadrant, so x will be minus tension AB cos of 22.62, and this is tension AB sine of 22.62. Okay, so this is resolving the inclined forces. Now if you want to apply equilibrium conditions, summation of Fx equal to, so this is minus TAB cos of 22.62, this is plus TBC cos of 6.71 equal to 0. Similarly, summation of Fy equal to, this is tension AB sine of 22.62, this is tension BC, sine of 6.71, and this weight of signal B is downward, means minus 300 equal to 0. Now if you solve this, if you find out cos and sine values, so these two equations are simplified as like this: 0.923 tension AB and 0.993 tension BC equal to 0. This is first equation. Then 0.385 tension AB plus 0.117 tension BC equal to 300. That is second equation. Okay. And if you solve these two equations simultaneously, you will get value of tension AB is 607.59 and value of tension BC is 564.76 Newton. So these are the values of two cable segments, tension in two cable segments. Now once this joint is over, now we can consider the next joint, that is joint C. Okay, if you look at the joint C now, okay, this is joint C. So weight of signal at C we have to determine, so it is WC, and this is tension in segment CD, and this is tension in segment BC, which we already now determine from the joint B. Whatever is this value tension BC, same is the value here also. So tension BC, this one we already determined, so the same value is taken here, tension BC. Okay, tension BC, that is 564.76. It is in third quadrant. If you look at here, it is in first quadrant, so opposite will be in third quadrant. This is third quadrant. Okay, now next is this cable. This is CD, it is in first quadrant. So this is tension CD, it is in first quadrant. Angle is 16.26 and 6.71, already we calculated in previous joint. Now in this joint C also we have to apply the same equilibrium condition, that is summation of Fx equal to 0 and summation of Fy equal to 0. Now only we have to pick up the value of tension BC from previous joint here. So now horizontal, this angle is 6.71 is with respect to horizontal, so horizontal component will be cos, vertical component will be sine. 16.26 also with respect to horizontal, so horizontal component is cos, vertical component is sine. Okay, so now resolve the forces. Tension CD is in first quadrant, so x component is plus, y component is also plus. This tension BC is in third quadrant, so x component minus, y component is also minus, and this is weight of signal at point C. Its weight is assumed as a WC. So now if you apply summation of Fx equal to 0, this is minus 564, this one, and this is plus tension CD cos of 16.26, this one. If you solve this value, if you take minus on right hand side, it become plus this one, 560.891, this complete value is coming, and then value of cos of 16.26 is 0.96, and if you take this on right hand side, and 0.96 will be divided to that, so that is 560.891 divided by 0.96. So the answer is equal to 584.26. Similarly, now once you find out tension CD, now our objective is to find out WC. So summation of Fy equal to 0 condition if you apply, this is plus tension CD 16.26 and this is minus 564 sine 6.71 and downward is minus WC equal to 0. If you substitute value of tension CD from this previous step here, so you will get this value is 0.28 into 584 minus 66 minus WC equal to 0. So this calculation if you perform minus 66, this is answer is 97.59 Newton. So this is value of WC, that is weight of signal at joint C. So like this you can solve the problem of equilibrium conditions of concurrent force system. If the body is attached with the cable segments, please remember cables are always subjected to axial tensile force, you can break the cable to consider the joint. Each joint is in equilibrium. So there are two joints in this problem, joint B and joint C, which we solve separately by applying a separate conditions of equilibrium. 3 forces in joint C and 3 forces in joint B. So like this you can solve the problem. I hope all of you have understand how to apply conditions of equilibrium in concurrent force system. In the next class we will solve the next problem on equilibrium of concurrent force system. Thank you very much.